Hey everyone, good afternoon, welcome. And let's have our class for today. Today is Monday, March 1st, so we are almost approaching the halfway point of this course. All right, halfway point of the course, so just want you guys to be aware of that. Also want to tell you some announcements. The big announcement is next Monday is your exam. So test 2 is going to be on next Monday, March the 8th. It's the same format as last time, 20 to 25 multiple choice questions opening up next week. And then there's a written portion that's opening up, I believe, Friday. So test 2 is multiple choice and a written portion. For your written portion, as always, please make sure you show your work so that we can give you partial credit. And that is going to be next Monday. All right, so that's number 1. Item number 2 is our second quiz is due next Monday. The way my system works is that the test and the quiz, the due dates are the same day. So quiz 2 is going to be due next Monday. And those are the two main important points. The third point is I'll have office hours this Sunday, the night before the exam, and that's 3-7. And I'll have my office hours from 5 p.m. to 7 p.m. Alright, so they will be through Zoom. So in case a lot of people want to come into my office, we'll just have it through Zoom. I'll give you that Zoom link later. It's a test review. Actually, it's not a test review. I'm sorry. It's just test questions if you have. You do not have to come to this. To these Sunday office hours, Sunday night office hours, totally up to you. And last time I did this, I think only 1 or 2 people showed up, but majority of the class got good grades, so do not need to come. And then just want to tell you about lab. We have a lab this Friday, and that's on rates of reaction. So I want to thank, I think it was 3 of you, so thank 2 of the 3 are here. Thank you for coming to the lab last Friday. I think they had a good time. If you did not make it last Friday, you can make it this Friday, and that's rates of reaction. So you guys that did do the lab, make sure you do your lab report and turn it in for points on Canvas. Okay. So test, quiz, hopefully I'll have a review Friday. Your test will cover chapter 13 and 14. There's a study guide on Canvas. There's a study guide on Canvas that will tell you what to look for. All right. So I'm aiming for this Friday to actually have a review. So make sure you come to Friday's class. And we'll try to finish up this chapter today and tomorrow, today and Wednesday.
We have homework.
Yes, thank you. Thank you, Adriana. Homework 14 is due Friday. All right, Adriana, thank you. Friday we have homework, and I'll put those 10 points in chapter 14, homework problems. Another thing is if you're doing the clutch prep, continue to do the clutch prep. Keep up pace with that, and I'll give you extra credit if you finish everything. I think 4 or 5 of you have signed up, so please make your $30 investment worth it. That will really help you learn the material. Not just my class, I believe the other professors have said it has helped their students immensely, so it's worth the $30 from what I hear. Anything else you guys can think of? So we'll finish up ice tables, and let's finish it off with this problem here. Right, first of all, I want to preface this by saying this type of problem will not be on the exam. Ice tables will be on the exam, but not this type of problem. This is a little bit more complicated, and so because it's more complicated, you won't have it. But if you know how to do this problem, the one on the exam will be like a piece of cake. Okay, so I choose to do the hard one so that the one you'll see on the test will be a piece of cake, or easy, so to speak. Right. So here we go. Let's go over this problem here. At 1280 degrees C, the Kc for the reaction is this. Okay, so notice the arrows. The back and forth arrows tells us that this is an equilibrium. So it's an equilibrium reaction with an equilibrium constant. Okay, so the equilibrium constant is 1.1 times 10 to the minus 3. Notice we quote the equilibrium constant at a specific temperature. Okay, initially. Okay, that's a word I want you guys to sort of highlight. Initially, the concentrations of Br2 is 6.3 times 10 to the minus 2. And the concentration of Br is 1.2 times 10 to the minus 2. So that's initially. Okay, initially is not the same as finally. Okay? See, the word here is initially. So initially I'm right here. Okay, standing here. Okay, if you push me, if Harper or anybody pushes me and I go back, okay, I'm not going to stand here and be idle. Okay, I'm going to come back to my equilibrium position. All right, so initially is not the same as finally. All right, so which means this reaction is going to have to settle. Okay, this reaction will have to settle because in an equilibrium, excuse me, okay, having mask issues today, because in equilibrium, okay, we'll have some reactants and some products at the end of the day. Okay, so calculate the concentration of these species at equilibrium. Obviously, we are not at equilibrium because initially, okay, we're like this. Okay, where are we finally? Okay, this will go back and forth until it settles. Which way will this go? Which way will it settle? Okay, so step one of this problem is to use the Gator rule to determine which way the reaction will shift. Which way will the reaction shift to get to equilibrium? So step one here. This is going to be a problem if I have to do this like this. So the step one here is to use the Gator rule, okay? Okay, compute Q. And then compare to K. To determine which way the ice table will shift. Okay, so on the exam, you'll have to do something like this. Okay, you're going to have to use the Gator rule. Let me turn off the lights. Compare Q with K to determine which way the ice table will shift, because remember, we're not at equilibrium. These are the initial concentrations. Okay, we want the final concentrations when this thing, reactants and products, settle. So let's do that here. So we're going to solve for Q here. Remember, Q is the same as K. So concentration of Br, we have to square it, divided by the concentration of Br2. Okay, everyone see that? Okay, everyone see where that 2 is coming from? The square. right, Br squared, the concentration of Br is 1.2 times 10 to the minus 2, so that's the same thing as 0.012. Don't forget to square it. Divided by the concentration of Br2, which is 6.3 times 10 to the minus 2. Okay, remember these entities are unitless. And on my calculator, I'm getting an answer of 0.0023. So that's our value of Q. Obviously, we're not at equilibrium. Okay, why are we not at equilibrium? Because our K, they tell us, is 1.1 times 10 to the minus 3. Here, our Q is 2.3 times 10 to the minus 3. So here's our value of Q. Remember, put Q first. Always put Q first or you'll get the wrong answer. Okay, our Q here is 0.0023. Our K here is 0.0011. Okay, so which is bigger? Okay, it's going to be Q, very good. So which way will the reaction shift? Which way are the alligator claws are pointing? Okay, they're pointing to the reactant side. They're pointing to the left. So this reaction is going this way. Okay. It's not at equilibrium. To get to equilibrium, it's going to shift to the left. Okay, the Gator rule tells us this. To get to equilibrium, under these initial concentrations, reaction will shift left. All right. So step 2 now is we'll set up our ice table, knowing that it's going to go to the left. Set up our ice table. Okay, so let me rewrite this reaction. Br2 gas is in an equilibrium with 2Br gas. Okay, just rewrite the reaction. Ice table is I, C, and E. Initial, change, and equilibrium. Initially, Br2 was 0.063. Right, everyone on the same wavelength with me? At Br, its concentration initially is 1.2 times 10 to the minus 2. Okay, which way will the reaction go to shift to an equilibrium? To the left. All right, so this is very important now. It's going to go this way, so this will not be minus x. Okay, so this is actually minus 2x because it's 2 moles, so it's minus 2x. That's a simple mistake people can make, easy mistake to make, minus 2x. Well, it's going this way. This one is going to be plus x. Okay, there's only one Br2, so it'll be plus x. So at equilibrium, we will be at 0.063 plus x. And then this Br will be at 0.012 minus 2x. Right, now let's go to step 3. Reaction shifts to the left. We set up our ice table, showing accordingly that it's going to shift to the left. Step 3 is to put into our equilibrium expression. Our equilibrium expression is K equals to Br squared divided by BR2. Right, K is 1.1 times 10 to the minus 3. BR at equilibrium is 0.012 minus x squared. 0.012 minus 2x, I'm sorry, squared. 0.012 minus 2x squared. Everyone see that? And then the squared, we know because of the law of mass action. Remember that equation. Right, everyone see this? This is what the reason why it's squared. All right, BR2 is 0.063 plus x. All right, from here on out, this type of math will not be on the exam. Okay, our goal here is to solve for x. So isolate and solve for x is our next step here, step 4. And this math will not be on the test. Step 4, isolate and solve for x. All right, so from here on out, we will not do this type of complicated algebra, but I'm going to go ahead and do it. Okay, I'm going to go ahead and do this so you can follow along, recognizing that if you can do this type of problem, you will, and understand it, you will be fine for the exam. Okay, see, you cannot take the square root of both sides. You see, this is a squared in the numerator. In the denominator, there is no square, so you cannot take square root of both sides. We will just have to do it the hard brute force algebra way. Okay, we'll have to do it the hard brute force algebra way. Okay. Right, the first thing I'm going to do is I'm going to expand this. Okay, everybody remember from math, a minus b whole squared. A squared minus 2ab plus b squared. So I'm going to expand that square. So 1.1 times 10 to the minus 3. Like I said, this will not be on the exam. A squared, 0.012 squared, is 1.44 times 10 to the minus 4. Okay, minus 2ab. Minus 2 times 2 is 4. 4 times 0.012 is 0.048x. Minus b whole squared plus b squared. B squared is going to be 4x squared. Okay, is this something that sort of rings a bell? Okay, we're all algebra pros, it seems like. Okay, so I know some of you have had calculus, so this is nothing for some of you. Okay, the denominator is 0.063 plus x. I'm going to take that 0.063 plus x and multiply both sides of the equation. Okay, both sides of the equation we will multiply by 0.063 plus x. So let me do that. 1.1 times 10 to the minus 3 times 0.063 plus x. Okay, remember, this whole thing, if you follow me, my fingers, this whole thing gets multiplied there. This I'm going to write as is. Multiplied 0.063 in both sides of the equation. This is algebra, okay, not chemistry. All right, I'm going to, like a train, I'm going to distribute. Okay, I'm going to multiply through these parentheses. So 1.1 times 10 to the minus 3 times 0.063. On my calculator, I'm getting 6.93 times 10 to the minus 5. plus, again, this is called the distributive property, plus 1.1 times 10 to the minus 3x. This is all on my calculator. Okay, so this has to equal to, I'm going to leave this as is. I'm going to leave this as is. All right, so this seems like a complicated situation, but I'm going to group all my terms together. All right, let's put all our terms together here. So I'm going to highlight here in orange the x terms. Okay. I'm going to take this and move it to the other side. So take this 1.1 times 10 to the minus 3. It's plus. I'm going to move it to the other side, making it minus. Okay, I'm going to leave the 4x squared as is. So it's going to be 4x squared. I'm going to move this to the other side. My x term when I do that is going to be minus 0.0491x. Okay, yes, it's a pretty messy math problem, I understand, but just bear with me. Minus 0.04x plus 1.1 times 10 to the minus 3 is this. This is my other term here. Okay, I'm going to highlight it in red, my constant term. This is my x term. Okay. My terms in red, under the red, 1.44 times 10 to the minus 4. I'm going to move this to the other side. Okay, I'm going to move this to the other side, making it minus. So this minus is 6.93 times 10 to the minus 5. On my calculator, I'm getting a plus 7.47. Plus 7.47 times 10 to the minus 5. That's what we call our constant term. Okay, plus, and this is minus. 1.44 times 10 to the minus 4 minus 6.93 times 10 to the minus 5 is 7.47 times 10 to the minus 5. And I moved all the terms out of here on the left-hand side, so what I have now is 0. Okay. All right, now I'm going to do what's called the quadratic equation. Everyone remember what the quadratic equation is? Okay. So like I said, this won't be on the exam, but this type of quadratics and all that, I did used to put it on the exam, but I won't do that anymore. So quadratic equation is this. Okay, so just follow along. It's going to be minus b plus or minus square root of b squared minus 4ac over 2a. Okay. In the old days, I would program it into people's calculators. You can actually get a graphing calculator, put the numbers in, and we'll spit it out. But now you won't. Okay, there won't be such a problem like this on the exam. Okay, so minus b plus or minus b square root of b squared minus 4ac. So let's put in our numbers here in our quadratic. Okay, minus b. Okay, this is a, b, and c. So minus b minus a minus is plus. So it's going to be plus 0.0491 plus or minus square root of b squared. So b squared. 0.0491 squared is 2.41 times 10 to the minus 3. Okay, just follow along if you're not familiar with the quadratic. B squared minus 4ac. Minus 4, a is 4. And then c is this number here, 7.47 times 10 to the minus 5. All of that divided by 2a. A here is 4. Okay, 8 here is 4, so 2 times 4 is actually 8. All right. So this is the form of the quadratic. This is the quadratic equation. This is how we will solve for x. Okay. Again, if you had algebra, this is all familiar to you. All right. So I'm going to go ahead and solve for this. Okay, this thing under the square root, by the way, again, this is math, not chemistry. Square root of b squared minus 4ac, that's called the quadrant. That's a math term. So I'm going to solve for the quadrant here. And when I do, something interesting happens. I get 0.0491. I take this term and I square root it, and I get plus or minus. Oh, I'm sorry. Okay, so I just, the quadrant here underneath the square root, and then taking the square root, and then taking the square root, I'm getting 0.0349. Okay, 349. That's the quadrant, square root of b squared minus 4ac, and my calculator is 0.0349. So now we have 0.0491 plus 0.0349 divided by 8. Okay, we have two answers in the quadratic. And we have 0.0491 minus 0.0349 divided by 8. So 0.0491 plus 0.0349 divided by 8. Let's do that on our calculator here. We get two answers from our quadratic. 0.0349 divided by 8. Getting 0.0105 big M. Okay, that's for the plus term. Okay, what about using the minus term? 0.0491 minus 0.0349 divided by 8. We're getting 0.00178. Okay, that's for the minus term in the quadratic. All right, so my question to you is, which term is the actual value of x? Is it 0.0105, or is it 1.78 times 10 to the minus 3? Okay, we went through all of this math. And we finally got a value for x. Unfortunately, we got two values of x, okay, from the quadratic equation. So which one is correct? Okay. Well, one of them has to be correct, and one of them we have to throw away. Okay. So which one will we keep, and which one will throw away? Okay, so this will give us to step 4. Again, you're not at this step on the exam, but this gives us to step 5 actually. Plug these values back in to ICE table. So we have an x value here that we have to plug in for x. Okay, we have an x value here that we have to plug in to our x. All right, so let's do this term here. Okay, so the concentration of Br2 is going to be 0.063 plus 0.0105. Okay, on our calculator, 0.063 plus 0.0105. 0.074 big M. Okay, I'll just make it to two significant figures. The concentration of Br. Okay, let's use this one here. It's going to be 0.012 minus 2 times 0.0105. Okay, plugging in 0.0105 back into our ice table. Get the alignments right. All right, let's do that on our calculator, plugging in our 0.0105 back up to here. 0.012 minus 2 times 0.0105. Actually, let's put parentheses properly. 0.012 minus parentheses 2 times 0.0105. Close the parentheses, a negative 0.009 m. Okay, is there such a thing as a negative concentration? Okay, can you have negative 0.009 concentration of something? Okay, something is wrong. We have to throw this out. Okay, this is the right answer. That goes into here. Okay. If we get a negative answer plugging this back in, then we did our math wrong. Okay. So let's plug this in, 0.00178, and see what we get. So we're plugging in 0.00178 into our ice table. So the concentration of Br2 at equilibrium. Concentration of Br2 at equilibrium is going to be 0.063 plus x, 0.063 plus 0.00178. Okay, what do we get when we put that in here? It's going to be positive. 0.063 plus 0.00178, getting 0.0065 big M. Here you want to put your units. And the concentration of Br. What is the concentration of Br at equilibrium? 0.012 minus 2x. Okay, here is our x that we found. We threw this one out because we got a negative. No negatives. So the concentration of Br is 0.012 minus 2 times x, 0.00178. Okay, let's do that on our calculator. .012 minus parentheses 2 times 0.00178. Close those parentheses. At 0.0084 big M. Okay, it's positive. Okay, cannot have a negative. 0.0084, and here you want to put the units big M. And that should be our final answer at equilibrium. Okay, our final step 6 is optional, but optional step 6 is to plug it back into equilibrium expression and make sure it equals the equilibrium constant. Okay, so step 6. Plug back into equilibrium constant. Okay, so this is to verify your right answer. Okay, this is to verify answer. All right, so K here is 1.1 times 10 to the minus 3. 1.1 times 10 to the minus 3 equals to BR at equilibrium is 0.0084. We have to square it. Divided by, so don't forget to square this term here. Divided by the concentration of Br2 at equilibrium, which is 0.0065. Okay, so this is our question. These are the concentrations we calculated. Okay, let's just double check our answer. Okay. This is a way to ensure that what you put on the test is correct. Plug it back in. Okay, 0.0084 squared divided by 0.0065. 0.01. That's not right. Did I do something wrong here? 0.0084. Yeah, if you round it, it'll be 1.1 times, but it should be 1.1 minus 2. I'm off by a factor of 10. That's strange. Here. Well, anyways, here's the answer. So anyways, I'm getting 1.1. You're right, but it's not. Is it 0.0? I must have done something wrong here, but that's okay. I'm not going to go back and double check it. Anyways, for those of you that are not following along, this is 1.1 times 10 to the minus 2. It should equal to 1.1 times 10 to the minus 3. But, yeah. Let me quickly check this out here, 0.063. Oh, I'm sorry. 0.065. There we go. All right. So our correct answer at equilibrium is going to be 0.0084. This is the right answer. Divided by 0.065. Okay, that's the right answer. So I had this one wrong. I was off by a factor of 10. So 0.0084 squared divided by 0.065. Yep, 1.1 times 10 to the minus 3. Okay. So our answer is correct. Okay, so what is our final answer at equilibrium? Our final answer of Br2 is 0.065 big M, and our final answer of Br at equilibrium is 0.0084. Okay, and I know that's right because I plugged it back in and I got the equilibrium constant. Right, so that's how you do this type of problem. All right. So you will not have to do the quadratic equation on the exam. Okay. So, right. But anyways, here's the problem. All right. Talk about pretty intense. Okay. We started out with this equation here with this problem. Okay. We used the Gator rule. We used the ice table. Okay. There's no real easy way to solve for x, so we used a quadratic. Here's all of our quadratic steps. We finally got our concentrations, and then we plugged it back in, and then we got the right answer. Okay, I know this is at equilibrium, and this is at equilibrium. All right, so there will be no quadratic on the exam. So, just so you know. Okay, on the exam, it will be more like last week's problem. Okay. This was last week's, this was Friday's, where you had to take the square root to find x. Okay, that's what you'll do on the exam. To use the quadratic to find x, we won't do that. Okay, we will not do that on the exam. But if you can solve this type of problem, you're good for ice tables, and you're also pretty good in your algebra. All right, you see I made a little bit of an algebra mistake, but I caught myself. There it was. All right, so that problem took 40 minutes. Can you believe that? 40 minutes? So that's a pretty intense problem. And that's okay. The last part of our chapter has to do with Le Chatelier's principle. Okay, so you'll have to excuse all the bleeding. There's a lab that you guys will have on Le Chatelier's principle, and it's pretty straightforward. It's nothing terribly complicated. The idea is this. If you perturb an equilibrium, what will it do? It will go back. Okay, it will do the opposite of your perturbation. It will do the opposite of your perturbation. So in other words,
Uh-huh. You want this one right here? Because it's not. Because I have it.
I'll just go with the next page. Okay, that's fine. You can have it back. I just need this sheet because there was no. I had to use the back sheet. Okay. Because the ink went through. Right. Very simple. If you don't make this more complicated than it is. Okay. If you perturb an equilibrium. If you perturb, another word, a fancy word for disturb, if you disturb an equilibrium, okay, the reaction will react. How will it react? Okay, if you push me back, okay, I'm coming back here. Right? If you push me, I'm going back here. Right? So the reaction will do the opposite of the perturbation. The equilibrium reaction, I should say. We'll do the opposite. Okay, it compensates. Okay, if you push me, what am I going to do? Am I just going to stand there? No, I'm coming back to my original place. So if you perturb an equilibrium, the equilibrium will do the opposite of the perturbation. All right, so let's say you have an equilibrium. Again, look at the arrows. If you have an equilibrium, okay, let's say in this equilibrium you increase the concentration of products. Okay, you increase the concentration of products. What's the opposite of increase? Decrease. Let me just write this out here. Okay, what's the opposite of increase is decrease. So what will the equilibrium do? It will decrease the products. Okay, what way? How will we decrease the products? Shift to the right. Shift to the left. Okay, towards the reactant side. Okay, shift to the left. Okay, reduce the products so the equilibrium will shift to the left. Increasing reactants, decreasing products. Okay, opposite. You always want to think opposite. Okay, opposites. The equilibrium reaction will do the opposite of what you do to it. Okay, if I push Josh back, he's going to come push me back. Okay, he's going to do the opposite. Okay, you punch, the reaction punches back. Okay, what's the opposite of decrease? If you decrease the concentration of products, Okay, what's the opposite of decrease? Increase. So here the reaction will increase products. Okay. Punches back. Okay, which way will the reaction shift if it wants to increase products? To the right. Okay, it's going to shift to the product side. Right, if you increase concentration of reactants, what's the opposite of increased reactants? The opposite of increased reactants is decreased reactants. That's what the equilibrium will do to counter what you did. So which way will decrease reactants? Left or right? The right. Okay. It will shift to the right, the product side. That's the only way you decrease reactants. Why? Because you increase the reactants. It fights back. Opposites. All right, finally, if you decrease reactants, you, the experimenter, decrease the reactant concentration. Okay, what's the opposite of decreased reactants? Increase concentration of reactants. If you increase the concentration of reactants, the equilibrium will shift to the left. Okay, that's how it fights back. It does the opposite of whatever you do to it. Okay, so you have to think the equilibrium reaction, equilibrium now, the equilibrium reaction will do the opposite, the complete opposite of what you do to it. If you disturb or perturb a reaction, it's going to go back and reverse what you did to it. Opposites, reversing, countering. That's what Le Chatier's principle is all about. All right, the last minute or so. Okay, the situation is a little bit different for gases. Okay, let's see if I can do one more minute, gases, because remember, gases are two things. Number one, gases have a concentration. But you also have to remember, gases exert a pressure. So this is Le Chatier's principle with regard to gases. Again, look at our arrows. Look at our arrows here. And notice the fact that we have gases. So this is tricky. I'm going to tell you guys. This is tricky. Okay. So gases exert a pressure. So let's say you do something. You increase the pressure of the reaction. Okay. So remember, Le Chatier's is all about opposites. Okay, what is the opposite of increasing pressure? What's the opposite of increasing pressure? Decreasing pressure. Okay, which side of the reaction has less pressure? The one with more moles or less moles? Less. Less. This is tricky. Which side of the reaction has less number of moles? You increase the pressure, the reaction fights back, so it's going to do the opposite of what you do to it. So if you increase the pressure, the opposite of increasing pressure is decreasing pressure. The reaction will shift where there is less pressure. The side with less pressure has less number of moles. So side with less number moles. So you literally have to balance your equation and count the number of moles in the reactant side versus the number of moles in the product side. Okay, so all of this is kind of tricky with gases. Okay, it's a little bit tricky with gases, and we'll complete the rest of this on Wednesday. I think Friday we'll have a review for our second test, and have a good day, everyone. This long 40-minute problem, it will not be on the exam. The quadratic will not be on the exam. Okay, so from here on out will not be on the exam. All right, everyone look from here downwards. Okay, quadratic equation, not on the exam.